For decades, we've stared at Mars, wondering if anything ever lived there. But our earliest exploratory missions had a blind spot. In 1976, the Viking landers touched down and ran a highly complex gas experiment, trying to detect the metabolic breath of microbes in the dirt. The results were confusing and largely inconclusive. The problem was structural. A lander is stuck exactly where it drops. If the soil right next to its landing pads doesn't hold the answers, the machine can't walk over to the next ridge to check for better geological context. To find signs of ancient water, space agencies realized they had to actively go looking for it. Throughout the 1990s and 2000s, they shifted strategy and began building mobile robots. That mobile philosophy culminated with the Mars Science Laboratory, better known as the Curiosity rover. NASA dropped this 1-ton nuclear-powered machine into Gale Crater with a very specific target: to drive up the towering slopes of Mount Sharp. Scientists knew they couldn't just test random surface dirt to answer the ultimate question of habitability. They needed a machine capable of driving physically through stacked layers of geological time. Curiosity began its journey at the very bottom of the crater, rolling over the ancient rock formations known as the Bradbury and Mount Sharp groups. As it drove, it found sub-rounded pebbles, stones physically smoothed out by water, and fine-grained mudstones. These sedimentary rocks are proof of ancient flowing rivers. Roughly 3.6 billion years ago, Gale Crater was an overfilled lake basin. The water here had a moderate pH and low salinity, meaning it wasn't overly acidic or choked with salt. Because we found those precise environmental conditions, we know the crater base was suited to sustain microbial life. The sheer thickness of these sedimentary layers tells us those lakes persisted for millions of years. To test for life markers, Curiosity uses an internal lab called SAM. A robotic arm drills a rock core, drops the powder into a hopper, and bakes it to read the evolved gases. Inside these gases, SAM detected specific organic markers, including chlorobenzene. The rover also uncovered sulfur-bearing organics inside the mudstones. Sulfur is durable. It binds to fragile organic precursors and acts like a chemical shield, preventing them from degrading under billions of years of harsh ultraviolet radiation. Finding these preserved organic molecules proves that the raw chemical ingredients and energy sources required for biological metabolism survived the planet's transition from a wet oasis to a dry wasteland. Curiosity didn't stop at the lake bed. It climbed higher into the Sicker Point group. The steep ascent took a heavy mechanical toll, grinding down the rover's wheels and forcing engineers to adopt their driving tactics to keep moving upward. As the elevation increased, the surface geology shifted. The wet lakebed mudstones disappeared, replaced by the wind-blown sandstones and the massive, dry Bagnall dunes. This chart maps the climate shift. As water declined, rocks reveal a rising curve of sulfur and chlorine isotopes left during evaporation. But water didn't vanish instantly. Through diagenesis, subsurface fluids circulated and baked rocks deep underground, long after surface lakes dried to dust. By physically driving upward and reading this transition in the rocks, Curiosity successfully mapped the exact timeline and mechanism of how Mars collapsed into an arid desert. Over its 8-year primary campaign, Curiosity definitively proved that Mars hosted continuously habitable environments that spanned millions of years. Its specific chemical discoveries now act as a targeting map. Because Curiosity proved that mudstones and sulfates act as preservation vaults, newer machines like the Perseverance rover know exactly which rocks to drill to hunt for fossilized microbes. And these discoveries directly inform human exploration. Curiosity spent years tracking atmospheric lechane fluctuations and measuring the high-energy radiation striking the surface. It also uncovered environmental threats in the modern dust, specifically toxic oxychlorines and perchlorates. We now know exactly what chemical hazards must be mitigated before human boots touch the ground. Curiosity wrote the definitive history of Mars's ancient, habitable past and provided the essential survival guide for humanity's eventual arrival.